Oh, right. So we're gonna finish the notes today. So we talked about Friday. We talked about differentiability. Okay. And a little bit on continuity. We talked about, we reviewed continuity because we did that first chapter of the year. And then we talked about how is something differentiable. Okay. So just to review, let's see here. For something to be differentiable means to have a derivative. For something to have a derivative, right? It has to follow these things. It has to be continuous. Okay. There could be no sharp turns, right? No sharp turns, no corners, no two curves meeting at one point, like this guy here, cusp point kind of thing. Um, so in order for us to check that, we use this over here in yellow. We have to check the limit of the derivative coming from the left side, and if that equals the limit of the derivative coming from the right side, that means there is a derivative at that point. Okay, if they're different, then that means we have a situation like this. If they're continuous but still different, the derivatives are different at one point, it's probably a situation like that. Okay, so that's where when we did a couple problems, but we stopped on number 3 or 4. I can't remember. Number 3. We didn't do number 3. We skipped number 3, 3 and 4. Okay. There's a reason I skipped it. I skipped it because they are different problems than the ones we did before. Number 1 and 2 were similar. Even 5 and 6. 5 and 6 were very similar. We didn't do number 5. Wait, are there 2 number 5s? We did one of the number 5s. We didn't do the other number 5, but it's very similar to what we've done before, right? So if we have time, we'll do it. Okay. If not, we did the one in the notes. So the ones I want to focus on today are number 3 and 4. Okay, because they're a little bit different than the ones we talked about. And you had one like this on the first test of the year on the FRQ, where you had to come up with A and B. You had to come up with what is A, what is B, but it wasn't differentiable. It was continuous. It was a continuity question. It's the same type of question though, just it's asking if it's in terms of differentiability. Okay, so we're going to check those rules. Okay, so to determine the values of A and B, which would result in the function being differentiable at -2. Okay, so they say it has to be differentiable at -2. So differentiable everywhere. -2 is the only place where there could be something with differentiability, right? Because it's the only place where the function changes. The top part is linear, the bottom part is quadratic. Okay. So, in order for something to be, hey, hang on to it. I'll come get it. Yeah, just hang on to it. I'll come get it a little later. In order for something to be differentiable, also remember, it has to also be continuous, right? If it's not continuous, it's not differentiable, right? These are the 3 kind of, I don't want to say cheat sheet things, but they're kind of reminders. If something is differentiable, it also has to be continuous. If something is continuous, not necessarily differentiable, you still have to check it. If something is not continuous, if you've proven it's not continuous, there's no way it can be differentiable. Okay, so if we show that it's continuous, we still have to check differentiable. We're going to do both for this one. Even though this question right here, the question we're doing right now, doesn't have anything about continuity. Doesn't have anything about continuity in there. I think we're going to need to do it. Okay. So let's check for continuity first. Anytime you do differentiability, you want to do continuity as well. Okay. So Let's check for continuity. Okay. So continuity, remember this is the rule for continuity. All of these guys have to be equal to each other. The limit of the original function coming from the left has to be equal to the limit of the original function coming from the right. If both of these two guys are equal, this guy has to be the same number. And then this number here is just plug in what's the solution at that point. What is just the solution at that value? Okay, so that's what we're going to check first. So again, remember, this question right here, this type of question, the one we're doing right now, is a free response type of question where you're figuring out A and B, free response type of question. So what they want to see here is they want to see you, how did you check continuity? Again, a lot of you do it in your own process, but it's not quite clear. So make it clear when you do it. So the first thing you want to do is define the limit, or sorry, put the definition there. For this one, it's the limit as x approaches -2. It's -2. So the limit as x approaches -2, we're going to start with from the left side, from the negative side, for f of x. We want to check to see if that's the same as the limit for -2 from the right side, for f of x, which is the same, which if those two guys are equal, then this guy, the overall limit's going to be equal, and then f of -2. Okay, so I just took the rule, took out c, put in -2. That's all I did, because it's specific to this problem. Okay, now what I'm going to do is I'm going to check those things, just like we did on Friday. Okay, it's going to be a little different though. Why is it going to be a little different when I check this guy? It's going to be in terms of A and B, right? It's not going to be numbers like we did last time, right? On Friday, when I checked continuity, I got a bunch of numbers, right? I got, for this problem, I got 6, 6, all of these numbers, right? This guy is going to be in terms of A and B. So I'm going to have some A's and B's in there. That's okay. That's okay. All right. Okay, so the first one, the limit as x approaches -2 from the left side. From the left side means the less than side. So the less than side is going to be this guy right here. So what I'm going to do for this is I'm going to do the same thing I've been doing. I'm going to plug in -2 everywhere I see an x. Not an A, an x. And I'm going to simplify it as far as I can. So here I get -6a plus 3. I can't simplify it any further. So I stop right there. Okay. Now I'm going to do the same thing for the other guy. I'm going to do the same thing for the other guy, but the other guy's coming from the right side. It's coming from the positive side, the greater than side. The greater than side, I'm going to use this guy here. So I'm going to plug in an x, -2 everywhere I see an x. So I get 8b plus 2 minus 3, which is the same thing as 8b minus 1. Because if you square -2, it makes a 4, and then multiply it times a 2 in front, it makes an 8, and then minus a negative makes it a plus 2. So I get 8b minus 1. Okay. All right. So let's see this one. So how do I do the next one? Which one would the next one be? It would be, yeah, it would be plugging in -2 to the first problem, right? Because it's equal. right? That's where I would plug it in if I were solving this for the limit. So it's going to be another negative 6a plus 3. And then the last one, what would the answer be for the last one? Or what would what would I have for the last one? It'd be the same one I had, yeah. It'd be the same one I had for the last one. If I want the solution at -2, then I have to plug it in to the first one, okay? So pretty much what I get here is negative 6a plus 3 is the same as 8b minus 1. That's pretty much what I get here. Because I have, or you can put equals, I can also put equals the same thing, equals the same thing, but we already know it's equal, so you don't have to repeat it. So that's what we get, right? And we could solve for one. I could solve for A, I could solve for B, right? I could do that. I'm not going to do that yet because I want to check differentiability now. Okay, just give me 1 second to pull up my notes. So when I check differentiability, I need derivatives, right? So the first thing I'm going to do is differentiability. I'm going to check differentiability now. Again, I'm going to state what I'm doing. This is what I'm doing here. The limit as x approaches -2 from the left for the derivative of x. Now it's the derivative of x is equal to the limit as x approaches -2 from the right for the derivative of x. That's what I'm stating I'm doing. A lot of you do the work and don't show me that. This right here is your justification. Without it, you don't get credit for justification. Okay? A lot of you will show this work here. A lot of you will show this work on a test right here. And that's it. And you'll lose a point. And you're like, why? I did it right. And I'm like, yeah, but your justification's not there. Why are these important? Why are these guys important and why are they equal to each other? Right? It makes sense in your head. I know it. I get it. But it doesn't make sense to someone reading this. Okay? I can't get in your head. I wish I could get in your head to see what you were thinking, right? Because I want to give you points, but I can't. But if you put this part up here, oh, that's what they were doing. They were proving continuity. They were showing continuity, right? So that's what you want to show. Okay? You want to show that. A lot of you are stuck on, I did it right. I should get all my points. No, right? I don't know what you did, right? It's the process. How many points is the question worth? Is the answer worth? 1 point. That's it. So I'll give you that 1 point, but the other 2 I'm going to take points off of, right? So you got to be sure to show your process. How did you get there? Okay. Okay, so let's do that. First thing is find the derivative. So we got to go back up here to the side over here. I'm going to find derivatives. Okay. So the derivative of the first one, a is just a number. Treat a like a number. Don't treat it like a letter. The only variables we have up here are x, and x, because a is a number. We just don't know what it is. Okay? So a is a number. So the derivative for the first one is just 3a. Okay, so 3a for x equals less than or equal to -2. The next one's going to be 4bx minus 1. because I used the power rule for that one. Okay. Okay, let's move it down here. Okay, so the derivative. So the derivative, excuse me, what's the derivative going to be for the first one? How do I do the first one? -2. How do I get this guy here? Mhm. Derivative of the first equation, right? So what is the derivative of the first equation? 3a, right? Where do we plug in -2? The derivative is 3a. Where do we plug in -2? The answer is you can't. So the answer is just 3a. The derivative at -2 is just 3a. Oops. So what about this guy here? What's the derivative at -2 from the right side? What's the derivative from the right side for -2? Plug in -2 there. So I'm going to plug in -2 for x. So -2 times 4 is -8. B minus 1. Okay. So let's just, like, again, it's solved for A. It's in terms of A and B. Here's my question now. Am I done? What does the question say? What did the original question say? That'll tell me if I'm done or not. What does the original question say? Hmm? I have to figure out what A and B are equal to, right? Mm-hmm. Well, this is what we're going to do. We've done this before. Again, like I said, you guys did it on the first test. A lot of you, most of you did this part correctly because it's the same as continuity. This guy here, it's linear. I have A and a B. So what I'm going to do is I'm going to get A's and B's on the same side. I'm going to get all the constants without an A and a B to the right side. Okay. So I'm going to subtract 3 over here. And I'm going to subtract -8b over here. So the 3's will cancel out. The 8b's will cancel out over here. So I get -6a minus 8b equals -4. Now I'm going to highlight that because I'm going to use it here in a second. I'm going to do the same thing for the equation I just did, for the A and B, for the derivative equation I just did. So I have 3a equals -8b minus 1. I'm going to add 8b to both sides. So I get 3a plus 8b equals -1. I'm going to highlight that because I'm going to use that here in a second. So now the two highlighted guys, they both look very similar. So I'm going to do it over here where I have room. I'm going to stack them on top of each other. Negative 6a minus 8b equals negative 4, and 3a plus 8b equals negative 1. Okay. So does anyone remember what we did first chapter to solve for a or b? Like I said, you did this on a test. What did we do for the first chapter? For the first, I think it was number 1, FRQ. You had one like this for continuity. What did we do? Does anyone remember? Not substitution. You're close. Very close. Starts with an E. When you want to get rid of something, what do you do to it? It starts with an E. Eliminate. Elimination. Elimination. Substitution is another method. Substitution works. But I think this one's a little easier for elimination, because if I add straight down, does anything eliminate? If I were to add straight down, would anything eliminate? The B's, right? The B's. That's what I want. I want the B's. I want something to eliminate, right? So the B's will eliminate, and I'll get negative 3a equals negative 5. Well, B's went away. So if the B's went away, I can solve for a letter. Divide by negative 3, divide by negative 3. I get a equals 5/3. So I got half of the answer. How am I going to get the other part of the answer? Yeah, Tommy? Anyone, yeah. Plug it into the top one, plug it into the bottom one. It doesn't matter. Solve for the other letter. I would probably plug it into the bottom one. Why would I use the bottom one? And maybe you would too. Compared to the top one. Smaller numbers and less negatives. Yeah, less negatives. It doesn't matter though. Mathematically, either one of them are correct. So under here, I'm going to plug it in. Anywhere I see an A, I'm going to plug in 5/3. The 3's cancel out. I get 5 plus 8b equals negative 1. Subtract 5 from both sides. 8b equals negative 6. Divide by 8 and reduce. You get negative 3/4. Okay. All right. All right. So now I want you to try the next one on your own. Okay. Try it on your own. Follow the steps we just did. It's very similar. And I want you to try that one on your own. Number 4. Okay, so for the first one, for continuity, I got negative 5a minus 6 equals 50b minus 20. I haven't, all I did was just find the equations all I did was plug everything into continuity and differentiability. I haven't finished the problem, but I just wanted to double check. Okay. And then for differentiability, I got a equals negative 20b plus 3. Okay. So now when you get those, you got to set them equal or put a and b on the same side, get a and b on the same side, because we're going to do some elimination here. Okay. So let me make this a little smaller so I have room to write. All right. So negative 5a minus 6 equals 50b minus 20. So I'm going to subtract 50b from both sides, and I'm going to add 6 to both sides. So I get negative 5a minus 50b equals negative 14. Okay, so that's going to be my first one, so I'm going to put that right here. Okay. And then over here, all I got to do is add 20b to both sides. So I'm just going to add 20b to both sides because a is already over there. So you get a plus 20b equals 3. Okay. I'm going to focus my attention over here because this is where I'm going to get a and b. If I add straight down, will anything go away? Right now. If I add straight down, will anything eliminate like it did last time? No, it won't, right? It won't. So what can we do though? There's some things we can do to help the procedure, help elimination. What's one thing we can do? There's a couple things we can do. Anyone remember how to do elimination? You learned about elimination in maybe 8th grade, but it's been a while. Okay, so is there anything we can do to eliminate? Because right now, if I add straight down, I would get negative 4a plus negative or minus 30b. Mhm. So yeah, if I could get rid of that negative 5 up here, right? So that's negative 5. If I could get rid of it and make it a negative 1, that would be great, right? So what would I do how would I do that process? How would I get rid of that negative 5? Not get rid of it totally, but just make it a negative 1. What would I need to do? How would I make this a negative 1? Does anyone know? How would I make it a negative 1? How do I make a negative 5 into a negative 1? Divide them all by 5, right? I could do that. Thank you. Okay, divide them all by 5. So what I could do is I could divide this guy by 5. Great, that would work. Divide this guy by 5. That would work. But what happens when I divide this guy by 5? It's an ugly fraction, right? It's an ugly fraction, and I don't want to have to deal with ugly fractions until the very end. It works. Don't get me wrong. You can do it. It works. Instead of that, what can I do, Riley? I think that would be a little easier because then I don't have to deal with fractions, right? Again, that division would work. It works. You can do it. But I don't want to have to deal with any fractions until the very end, right? So what I'm going to do is what Riley said. I'm going to multiply 5 times everything on the bottom. Can't just do it times a. I got to do it times everything. Okay? So the top is going to stay the same. The bottom is going to be multiplied by 5. So everywhere I'm going to distribute a 5. So I get 5. Ooh, put a B there. I should put an A there. 5a plus 100b equals 15. Add straight down. Now the a's go away. I get a 50b right here. And I get a, what is that, a 1? Positive 1? Divide by 50. b equals 1/50th. Okay. Again, I get an ugly fraction, but it's at the end. Okay. So I plug it back in. Doesn't matter if you plug it back into the top. I could plug it in anywhere. I can plug it into the original top. I can plug it into the original bottom. I can plug it into any of these guys too. So you have 4 places you can plug it in. Pick the easiest one. I would probably pick the original because there's no negatives, or the new bottom, the new second equation. There's no negatives. That's why I would probably plug it in. But you don't have to. You can plug it in wherever you'd like. I'm going to plug it into to the new bottom. So I get 5a plus 100 times 1/50th equals 15. So 150 can be divided by 50. So that makes a 2 and a 1. So I have 5a plus 2 equals 15. Subtract 2 from both sides. I get a equals 13 over 5. Leave it like that. Don't change it to a decimal. Don't change it to don't change it to 2 and 3/5 or whatever it is. Leave it like that. Just reduce it if you can. Okay. All right. Okay, since we have, 13 minutes left, we don't have much time. I want you to do the last problem on there, the second number 5. Do the second number 5. Do that one. It's the same question? Let's change it up then. Okay, let's see here. Okay, so change it to this. So just change up some words. The there you go. So change the insides equation. You're gonna take your equations, and then you're gonna have to change the part where it says x equals 1. But besides that, you should be fine. You don't have to change. Given the piecewise function defined below, answer the questions at the bottom of the page regarding the continuity and differentiability of f at. You don't change that part. You just have to change the x part and then the function. And I'll replace it in the notes. So sorry. So I got this guy was not continuous at 1 because the first from the left side you're at -5, and then on the right side you're coming in, you're 5. So it's not continuous. So do I need to continue to check to see, do I need to continue for differentiability? Let's see. Which one of those dots says I don't need to check for continuity or differentiability? Number 3, the third one. If it's not continuous, there's no way it can be differentiable. So you just write that in. You just write that in. You just write that in after the problem. After you've shown that it's not continuous. Where is it? Let's see, right? Cannot be differentiable. So neither. Okay. So just be careful when you're using those. When you're using those things here, make sure you double check these here, because sometimes what some people will do is they'll check continuity and they're like, nope. Or they'll check continuity and they'll say, yes, it's continuous. So that means it has to be differentiable. No, you got to check differentiability, right? You got to check that one too. Okay, so make sure it's on the list. If you check differentiability first and it's not differentiable, you still got to check continuity. Okay, because if it's differentiable, you don't have to check continuity. It's already continuous, right? And just like we did, if it's not continuous, then it's not differentiable. But sometimes some people say, oh, it's not differentiable. That means it's also not continuous. No, not necessarily. Or sometimes you'll say it's continuous, so it has to be different. No, not necessarily. Okay. So just make sure you stick to that list. If you don't remember the list, do both. Just do both to check. Okay. All right. Okay. So there's a new assignment posted on Delta Math. Okay. What was I going to say? It's not due till Wednesday. It's not due till Wednesday by the end of the day. All righty.